Today's video is about geometric sequence. In an old fable, a commoner who had saved the king's life was told he could ask the king for any just reward. Being a shrewd man, the commoner said, "A simple wish, sire. Place 1 grain of wheat on the first square a chessboard, 2 grains on the second square, 4 grains on the third square, continuing until you have filled the board. This is all I seek." A chessboard has 64 squares. A. Fill out the table. According to this story, in the first square, there is 1 grain of wheat. The second square, 2 grains of wheat. The third square, 4. The fourth square, 8. Fifth square, 16. Sixth square, 32. Seventh square, 64. Let's check the pattern. 1, we can write down 2 to the 0 power. For 2, we can write down 2 to the first power. 4, 2 to the second power. 8, 2 to the third power. 16, 2 to the fourth power. 32, 2 to the fifth power. 64, 2 to the sixth power. How many grains of wheat on the 27th square? Let's check the pattern. 1, we got 2 to the 0 power. For 2, we get 2 to the first power. 3, this is the second power. 4, third power. According to this trend, we know how many grains of wheat on the 25th square. It will be 2 to the 24th power. How many grains of wheat on the nth square? It will be 2 to the n minus 1th power. Definition of a geometric sequence. In a sequence, if the ratio of any term and its previous term is a constant, it's a geometric sequence. Decide whether the sequence formed by the number of grains of wheat on the square of the chessboard above. We have the sequence 1, 2, 4, 8, 16. We could say 2 over 1 equals 4 over 2 equals 8 over 4. That equals 2. So this is a geometric sequence. Look at the E. Compute the total number of grains needed to do this. Use a formula S sub n equals U sub 1 R to the nth power minus 1 over R minus 1. From this sequence formed by the story above, we know U sub 1 equals 1, U sub 2 equals 2. So R equals U sub 2 over U sub 1 equals 2. And S sub 64 equals U sub 1 is 1, 2 to the 64th power minus 1 over 2 minus 1. Go to calculator. This commoner will receive 1.84 times 10 to the 19th power grains. If we want to calculate how many pounds of grains the commoner will receive, we will use 1.84 times 10 to the 19th power divided by 7,000 equals. It will be 2.64 times 10 to the 15th power pounds of grains. You can imagine how rich the commoner will be. F. If usable 1 grains of wheat are placed on the first square of a chessboard, and the grains on the successful square will be doubled than the previous one. How many grains on the 25th square? What about nth square? For the first square, there are usable 1 greens. For the second square, usable 1 times 2. For the third square, usable 1 times 2, then times 2. We have usable 1 times 2 square. For the fourth square, usable 1 times 2 times 2 times 2. So usable 1 times 2 to the third power. According to this pattern, in the 25th square, we will have usable 1 times 2 to the 24th power. For nth square, we will have usable 1 times 2 to the n minus 1th power. For J, if usable 1 grain of wheat are placed on the first square of a chessboard, and the grains on the successive square will be r times than the previous one, how many grains on the 25th square? What about the nth square? For the first square, we have usable 1. Second square, usable 1 times r. Third square, usable 1 times r times r. So we have usable 1 times r squared. For the fourth square, usable 1 times r, then times r. So we have usable 1 times r to the third power. For the 25th square, we will have usable 1 times r to the 24th power. For the nth square, usable 1 times r to the n minus 1th power. Usable n equals usable 1 times r to the n minus 1th power. This is the general form of a geometric sequence. This r is called the common ratio. From this general form, we could say this is an exponential function with a domain natural numbers. Let's talk about the difference between exponential function and a geometric sequence. For exponential function, domain is all real numbers. For geometric sequence, domain is all natural numbers. From the graph, you could say exponential function is a curve. For geometric sequence, the graph is made of certain dots. So you could say geometric sequence is a special exponential function. We know this too is called the common ratio. In the exponential function, we call this two is a base. Determine whether each sequence is a geometric sequence. Then find the 6 terms of each of the following sequences. According to the definition of a geometric sequence, the ratio of any term and its previous term equals a constant r. Then we call this sequence is a geometric sequence. Therefore, we need to work out -1 over 8 over 1 over 16 equals -2. 1 over 4 divided by -1 over 8 equals -2. -1/2 divided by 1 over 4 equals -2. So it is a geometric sequence. For geometric sequence, this is a general form. Usable n equals usable 1 r to the n minus 1th power. According to this pattern, we could say usable 10 equals usable 1 r to the 9th power. Usable 20 equals usable 1 times r to the 19th power. So usable 6 equals usable 1 r to the 5th power. From the given sequence, we know usable 1 equals 1 over 16. R equals negative 2. So we plug in 1 over 16 times negative 2 to the 5th power equals 1 over 16 times negative 32 equals negative 2. Let's go to number 3. Consider the sequence 12, negative 6, 3, negative 3 over 2. Show that the sequence is a geometric sequence. According to the definition, as long as we can show u sub n over u sub n minus 1 equals constant number r, then this sequence is a geometric sequence. So for A, we know this is u sub 1, u sub 2, u sub 3, u sub 4. Negative 6 over 12 equals negative 1 over 2. 3 over negative 6 equals negative 1 over 2. Negative 3 over 2 divided by 3 equals negative 1 over 2. So it is a geometric sequence. For B, find its 13th term as a rational number. For geometric sequence, we know general form u sub n equals u sub 1 r to the n minus 1th power. So if we have u sub 9 equals u sub 1 times r to the 8th power, we are looking for u sub 13 equals u sub 1 times r to the 12th power. We know u sub 1 equals 12, r equals negative 1 over 2. So we plug in 12 times negative 1 over 2 to the 12th power equals 3 over 1024.